Okay, so looking at section 2.2, we are focusing on linear equations. And when I hope that you remember that what I've been saying all along in Algebra 2 is that one of the main goals is to look at infinite solutions for variables. And specifically, when we're looking at functions, we're looking at infinite solutions for an input and an output. In other words, you might say for an x and a y. So we're going to start with one of the main functions. You've already seen these. They're called linear functions. And a linear function is a function whose graph is a line, represented by a linear equation. What this means is when you start graphing all of the solutions to a linear equation, the pattern of ordered pairs will always create a line. So when you're asking yourself, well, what is a solution? A solution is any ordered pair that makes the equation true. Let me give you an example. Let's say I have a function y equals 2x plus 1. One example of a solution is if I plug in 0 for x, then I would have 2 times 0 plus 1 would give me an answer of 1 out for my y. So one solution to this equation is 0, 1. And when I start graphing all of the solutions to this equation, here's 0, 1. When I start graphing all of them, I might plug in a number of 1 and I would get out 3. All of the solutions form a line. So we have solutions that work for x and y, and this is what would look like a linear equation. So we're going to focus on just linear equations and see, okay, well, what do we know is true about them? In many linear equations, you will have two solutions called a y-intercept and an x-intercept. A y-intercept would be the point at which the line crosses the y-axis. It's always where x is equal to 0. Just like here, you see in this picture, 0 comma some number would give you your y-intercept. The x-intercept is the point at which the line crosses the x-axis, and this is always where y equals 0. So since you can create solutions to a linear equation and graph them, this is one method you could use to graph any line, any linear equation. You would set your equation equal to y, choose 3 values for x, and you'll see why I say strategically in a moment. Solve for y and plot your coordinates and draw the line, draw the pattern that occurs from your solutions. So let's look at example 1. Graph the equation y equals -4/3 x plus 2. List the domain and range in interval notation. Okay, I've given you a setup of how I'd like your charts to look, especially for tonight's homework. And that setup's going to include your input, your x, then your function, what you're doing to x, -4/3 times x plus 2. That will give you out your y, and that will tell you what your ordered pair is that you will be graphing. Now, to find what shape this line will look like, we know it's a line, but we don't know if it'll face this way or up or down. To find the shape, we are going to plug in values for x and see what pattern arises. So before I do that, I want to look and say, hey, what would be good values to plug in for x? Well, look what we're doing to x. We're multiplying it by -4/3. So what numbers would be nice to multiply by -4/3? And hopefully you're thinking powers of 3. Let's try just -3. If I plug in -3 here, I have -4/3 times -3, which I'll write that as -3/1, plus 2. Why was that a nice number to choose? Well, look what happens to the 3's. They get reduced. 3 goes into itself one time, 3 goes into itself one time. -4 times -1 is +4. 4 plus 2 is 6. So I have the ordered pair -3, 6. And I can plot that. -1, 2, 3, +6, 1, 2, 3, 4, 5, 6. And there's one solution to my linear equation. Another good strategic value to always choose is 0, because it's always nice to multiply numbers by 0. If I plug in 0, I have -4/3 times 0 plus 2. 0 plus 2 gives me 2. So my answer, my solution would be 0, 2. So I plot that, 0, 2. And for tonight's homework, I would like you to have 3 values in your table. So let's go ahead and let's choose another value. Well, positive 3 would be a nice thing to choose. So I have negative 4/3 times positive 3, and I'll put that over 1 since I'm working with fractions here, plus 2. The 3's get reduced, and I have negative 4 plus 2, which would be negative 2. And there's my final solution that I need to see the pattern that arises, and that would be 3, negative 2. Now I can see the shape of this line. It's being slanted like this, and I can connect all those points. Okay, remember your domain are all of your x values. We chose those 3 points strategically. But are there any limitations on what we could have chosen for x? Meaning, are there any numbers I could not have chosen? Look at your function. I could have chosen 0, I could have chosen 1/2, I could have chosen 1. I would have got some weird fractions out, but those are still real numbers. So the answer is no, there's no restrictions. So my domain, my x values, would be anything from negative infinity to infinity. In the same way, my range, my y values, well, I'm getting all different types of y values out. If I take a look at my graph, I have y values that exist all the way down here. They line up with my y-axis, and it keeps going forever. And all the way up here, lining them up with my y-axis, it keeps going forever. So in the same way, my range is also negative infinity to infinity. And yes, the domain and the range will always be this, what you see, negative infinity to infinity, for lines, linear equations. Okay, let's flip it over. Example 2 is similar. We're going to be doing the same thing, but what do we have to do first before we can set up our table? Hopefully after looking at this equation, you answer yourself, oh, we need to solve for y. So let's do that. We subtract 4x first, so we have 2y is equal to negative 4x plus 6. Here's something tricky. I tend to get a lot of mistakes on this. When I divide y by 2, I have to divide everything on the other side of the equation by 2 to keep the equation balanced. So this becomes y equals negative 2x plus 3. Okay, there's our function. Let's create our table. X, negative 2x plus 3. Y will give us our ordered pair. And let's strategically choose points for x. Okay, there's no fractions here, so x is just being multiplied by negative 2. What numbers would be nice to multiply by negative 2? Well, in my opinion, negative 1, 0, and 1 would be nice, because I like multiplying numbers by 1. So I have negative 2 times negative 1 plus 3 gives me a positive 2 plus 3, which is 5. So I have the point negative 1, 5. And I go over negative 1, up 1, 2, 3, 4, 5. Plug in 0, negative 2 times 0 plus 3 gives me 0 plus 3, which is 3. So I have the ordered pair 0, 3. 0, 1, 2, 3. And lastly, 1. So I have negative 2 times 1 plus 3 gives me negative 2 plus 3, which is 1. And that gives me the point 1, 1. I can plot that. Now I can see what shape these solutions are, or what pattern is occurring here. It is a line, good, because it's a linear equation. And we have a line that looks like this. Our domain, again, there's no restrictions on x. We could have put anything we wanted for x. We chose negative 1, 0, and 1 because we knew they'd work out nicely. But there's no restrictions, so we would say negative infinity to infinity. In the same way, our range, we're getting all types of numbers out. So that would be negative infinity to infinity. Okay, after just doing 2 examples, and I know you've done a lot more in your past, you're going to start noticing some patterns that occur for all lines. all lines have some type of a slope to them. If I look at this, this is slanted in this way. I might have a line slanted in this way. They have a steepness to them. So after looking at many lines, we were able to determine how to find the slope of any linear equation. The slope is the ratio of the vertical change to the horizontal change. It's also known as rise over run. And I know this didn't get copied very well, but you guys know this. Change in y over change in x. And we have a formula that we can use which works for all lines to tell us how steep the line will be. And that's if you have two coordinates, an x1, y1. So this is if you're given an x1, y1 and an x2, y2. The formula to find the slope is y2 minus y1 over x2 minus x1. And notice this is the slope formula as long as the denominator, which is right found up here, cannot equal 0. Because we know we can't have a 0 in the denominator. Okay, so let's try this. Find the slope of the line through these 2 points. So we have an x1, y1, our first point, an x2, y2, and we plug that into our formula. We take negative 6 minus 7 over 8 minus negative 2. Negative 6 minus 7 would come out to be a negative 13. When we minus a negative, it becomes a positive. So 8 plus 2 is 10. We would see that the steepness of this line is negative 13 over 10. And this is going to be very helpful for us to use come the next page. So keep this in mind and let's flip it over. This page is review, so if you wanted some extra practice, you could do that, but we just did that, so we're going to actually move into our next piece. Okay, since all lines have patterns to them, they have a steepness, they have a slope, there's always an x and a y variable, we actually have some consistency, some formulas we could use when we're working with linear equations. Now I want you to think about something. I have a full name. My whole name is Cassandra Prempis. But I only use that when I'm in the context of like a doctor's office. If they're like, hey, what's your full name? Or hey, you're filling out a social security card, give me your full name. I say, okay, Cassandra Marie Prempis. However, when I go out with my friends, I do not use that name. Nobody calls me Cassandra. If I'm with my friends, they'll call me Cassie. And that's the name that I use in that context. However, if I move into another scenario and I'm at school, only students don't call me Cassie, they call me Mrs. Prempis. So depending on which scenario I'm in, depends on the name I use. In the same way, depending on different contexts that we're in when working with lines, we might use a different form of the name of the line. One name is called the standard form, and this is really only used when graphing. Point slope form, this is the form we're going to use quite frequently. We use it when given a point or the slope of a line. And lastly is slope-intercept form. This is also very helpful in graphing. M, the number that's multiplied by x, always lines up with your slope, and b lines up with your y-intercept. The more you can understand how these equations are used, the easier it will be to pick which equation should I work with depending on what's given to me. Like, hey, what context are you in? Are you with friends? Are you at school? Are you at a doctor's office? What name of the line should you use? So let's try some examples and we'll see what to do. Example 3. It says find the slope of the line and then graph the line. Okay, well if I want to find the slope, probably the easiest form to use would be slope-intercept. Slope-intercept. Why is that form helpful? Well look, the slope is whatever number is multiplied for x, as long as the equation is set equal to y. So let's take this equation and we're going to set it equal to y in order to find the slope. So right now I have negative 7x plus 2y equals 8. Need to get y by itself, so I will add 7x to both sides. That gives me 2y is equal to 7x plus 8. Divide everything by 2. And that gives me y is equal to, I'm going to call that 7/2 x plus 4. Okay, now that I've converted it to this form, it's very easy to identify the slope. The slope is that number right here. My slope would be equal to 7/2. So I found the slope. Now it says graph the line. Well, the beauty of slope-intercept form is they give us one point. They give us the y-intercept. So here's my y-intercept, 0, 4. And then I can use the slope to find other solutions to my line, other points. So let's graph the y-intercept, 0, 1, 2, 3, 4. Let's use the slope of 7/2. So remember, that means you could go up 7 and to the right 2, or we could do a negative divided by a negative, which is still a positive. So we can go down 7, 1, 2, 3, 4, 5, 6, 7, left 2, and graph my line. And there is my line. And I can even label what those 2 points, those 2 solutions are. 0, 4 works, and negative 2, 1, 2, 3, negative 2, negative 3 works. How could I check to make sure I graphed it right? Well, plug in negative 2 for x and negative 3 for y and see, does it equal 8? Is this a solution to your linear equation? And yes, it would be. Okay, let's keep moving on. Write in point-slope form an equation with slope 3 and the point 6, 2. Well, this example is pretty straightforward. They tell us which form we should use, point-slope form. So let's rewrite it just to make sure that we know it. It's y minus y1 equals the slope times parentheses x minus x1. Okay, my slope, that's my m in the equation. My points, that's my x1, y1. So I just plug it in, and I have y minus 2 equals my slope, which is 3, times parentheses x minus 6. That's it. That's point-slope form. That's all I have to do. So I just box that. Oops, sorry. Hope you can see that. All right, let's flip it over. As you start becoming more familiar with equations of lines, there's certain types of lines that come about that have different features to them. A horizontal line goes straight across, and the slope of a horizontal line is always 0. When you're writing the equation of a horizontal line, it's kind of an exception to the rule. We don't use point-slope form, standard, or slope-intercept. It's always just y equals some number. In a similar fashion, a vertical line is also different. The slope is undefined, and the equation of the vertical line is always x equals some number. Perpendicular lines occur when you have opposite reciprocal slopes, or in other words, negative reciprocal, people like to say. Parallel lines occur when the slopes of the two lines are the same. Okay, let's practice working with these exceptions to the rules. So, example 5. Write an equation of the vertical line through to 3. So if I see the word vertical, I don't want to use point-slope form, slope-intercept, or standard. Instead, I want to know that it's easier. A vertical line is always x equals some number. Well, what is that number? It's always x equals the x coordinate. So in this case, this is 2. Those of you who are more visual, let's take a look at it on a graph. If I have the point 2, 1, 2, 3, 2, 3, and I draw a vertical line through this point, well, math, there's a ton of consistency in math. Let's see what's consistent on this line. This is the point 2, 0. This is the point 2, negative 1. This is the point 2, negative 2. This is the point 2, negative 3. What's the pattern that you're seeing? What's happening on this vertical line? Every x coordinate is 2. So that's why our equation is x equals 2. Okay, let's look at the horizontal line. Horizontal line is y equals the y coordinate. So in this case, it would be y equals 1. And again, more visual people, let's take a look at that. 1, 2, 3, 4, 5, 6. 1, if I draw a horizontal line, here's the point 0, 1. Here's the point, or let's look at this one here even, 4, 1. Right away I see a pattern. All of the y coordinates are 1. So the equation is y equals 1. All right, let's keep moving on here. Write in point-slope form the equation of the line through the pair of points. So they didn't make us guess. They said, hey, here's the equation you need, point-slope form. So we have y minus y1 equals m times parentheses x minus x1. x1, y1 represents any point on your line. So they gave us 2 of them. Let's just use the first one, x1, y1. I can plug that in. I have y minus 3 equals, ooh, I'm missing that slope, so I'm going to leave a space for me, x minus negative 10. How do I find the slope here? Well, hopefully you're saying, oh, you have 2 points. You have an x1, y1 and an x2, y2. So we can use that formula that we know is used to find slope. Slope is equal to y2 minus y1, so negative 5 minus 3 over x2 minus x1, negative 2 minus negative 10. Negative 5 minus 3 is negative 8. Negative 2 plus 10 is 8. So that slope simplifies to a negative 1. And that's it. But we can simplify here. We have a minus a negative. So we would just simplify that and call this y minus 3 equals negative 1 times parentheses x plus 10. All right, flip it over. 3 more examples. Now is where it starts to get tricky. It says write the equation of the line through 1, 2 and parallel to this line. Okay, when they don't tell you what type of an equation to write, but they say write an equation, always use point-slope form. Point-slope. Why do I say that? It's the easiest. So let's write it. Y minus y1 equals m times parentheses x minus x1. Remember, x1, y1 refers to any point on your line. So we have a point on our line. Our point is 1, 2. That's our x1, y1. So let's fill that in. We have y minus 2 equals, I don't know my slope yet, x minus 1. Okay, how can we find our slope? It says your line is parallel to this one. This line is in slope-intercept form. So what's the slope of this line? Hopefully you're saying, oh, it's 4. So what would be the slope of a line parallel to that one? Well, here's where you have to recall parallel lines have the same slope. So it would be 4. That's it. I wrote an equation. It's a nice, easy one, and it backs it. Okay, I'd like you to try example 7 on your own. Actually, let's do this one together. It says write in slope-intercept form an equation of the line through this point and perpendicular to this. Okay, they tell us what form it needs to end in, but again, whenever you're asked to write an equation, start with point-slope form. So let's try that. Y minus y1 equals m times parentheses x minus x1. Here's our point on our line, x1, y1, so let's fill it in. Y minus negative 1 equals, I don't know my slope yet, parentheses, x minus 8. How do I find my slope? Well, here it says it's perpendicular to this line. This line, again, has a slope of 4. What would the slope of a line be perpendicular to that? Well, perpendicular lines have opposite reciprocal slopes. So if I look at this as 4 over 1, the opposite would be negative, and the reciprocal would be 1 over 4. So now I have that slope. If they said write an equation, sweet, I'm done. But they said now take that equation and write it in slope-intercept form. So after we've written this equation, how can we change it to this form? Well, we just need to isolate y. So let's do that. We have y plus 1 equals negative 1/4 times x minus 8. Distribute the negative 1/4. So I have negative 1/4 x plus 2 equals y plus 1. Subtract 1, and now I have y is equal to negative 1/4 x plus 1. And I box it. Okay, last example, example 8. It says, given this equation, write the equation in slope-intercept form, and then find the slope and the intercepts of the line. Okay, slope-intercept form, again, that's y equals mx plus b. You do have to have these forms memorized, and I know you've already worked with them in geometry and algebra 1. So here's our equation. Let's convert it to slope-intercept form. We have negative 3x minus y equals 2. Slope-intercept form always isolates the y, so we're going to add 3x to both sides. That gives us negative y is equal to 3x plus 2. Divide by negative 1. That gives us y is equal to negative 3x minus 2. Here's slope-intercept form. Okay, it says find the slope and the intercepts. Well, our slope lines up with what's multiplied by x. So our slope is negative 3. Our y-intercept is this number over here, so we can write that as 0, negative 2. How do we find our x-intercept? Well, earlier in this lesson, we looked at the fact that our x-intercept is where y equals 0. So let's take this equation. Let's replace y as 0. We have 0 equals negative 3x minus 2. And let's solve for x. And that will give us our x-intercept. So we add 2. That gives us 2 is equal to negative 3x. Divide by negative 3. And we see that our x-intercept is at negative 2/3. So the x-intercept you could write as the point negative 2/3, comma, y is always 0. Okay, and that would be our answers: x-intercept, y-intercept, slope. Sorry.